The purpose of this video is for you to be able to draw and explain examples of equilibrium shift. You got to remember left and right. Now, some key terms. Left shifted or left shift means that the reaction favors the reactants, and you're going to have higher concentrations of reactants than products when the system is at equilibrium. And on the flip side, right shifted or right shift means the reaction favors the products, and you've got higher concentrations of products than reactants when the reaction achieves, or when the system achieves equilibrium. Now, here's an example of equilibrium shift for cats on a mat, and this is left shifted. You got to remember the reaction. In this case, off is the reactant and on is the product. So here's our reaction, or our equation. The reaction is them getting off and on the mat. And you can see the way the arrows are drawn that this system favors them being off the mat for whatever reason. It's going to look like this. You're going to have less cats on the mat than off the mat. So more cats are off the mat. Now, you still have cats getting off and on the mat. This guy's getting off and this guy's getting on, or else the system wouldn't be considered to be at equilibrium. Now, here's it for when it's right shifted. Now here the arrows, the longer arrows flipped. Now it's pointing to the product side. And you're going to have more cats on the mat than off the mat. Now, a chemical system could look like this. So you've got a reaction where two single things are coming together to make one thing. This is left shifted. I'm going to favor my reactants. That means A and B. And when the system is at equilibrium, I'm going to have more of A and B. As you can see, I've got lots of singletons and very few pairs. And I'm still going to have them coming together and splitting apart at equal rates. Now, the opposite, I'm going to have a lot more pairs in my system, and that's what it's going to look like. And that's how you would draw and explain examples of equilibrium when it's undergoing shift.